Alrighty, guys. So I was hoping to get a little bit of a video to explain some math concepts. I have my trusty old whiteboard. It's a good one. It's a little old, a little scratched up, a little well loved. And I wanted to walk you through problem 15 because there were a couple of people that had some questions about it. But this is adding in scientific notation, and then we're also having to include the rules regarding significant figures. Okay, so one thing to note is that each of these values, actually, when it's given to you, I don't believe there's parentheses around it, but one thing that you can do to help kind of delineate what the expression is asking you to do is to use parentheses. It can be helpful. Okay, and then to note that each of these, 1, 2, 3, 4, has 4 significant figures. Remember that zeros between non-zeros are significant. So when you have a digit that's in between 2 non-zeros, those are significant digits. So we have 1, 2, 3, 4 significant digits, or figures. If you didn't read the rest of the article about significant figures and you really don't know what's going on yet, you need to stop right now, head back and read the rest of the math tools for physicists, and really get a handle on significant figures, or at least know where to find the rules and kind of work yourself through them. They're really like kind of like these logical rules, that apply with specific qualifications to different values. And we will be talking about these, but not until we get back from our 3-day weekend. We're going to definitely enjoy that. But I know that some of you want to work ahead. And so you're diving into this and you'd like a little more instruction, and that's where we are. Okay, so this, for some reason, this was inputted into the key as 1.100, and I was like, whoa, somebody did their addition wrong. That happens. And so that, if you were getting marked that it was incorrect and you did the math right, that may be part of it. But the other thing that it asks you to do is pick the right significant figures. And so that may be where things went wrong. With any addition problem using scientific notation, it's a lot like any of these problems over here that are examples of the distributive property. And I want to just kind of set that up. When you have some kind of expression within a parenthesis, and there is a value outside of that parenthesis that's going to be multiplied by whatever's on the inside, we can apply what is called the distributive property. So that basically is saying, like, if you have an expression like x plus y, and you're multiplying that whole value by some number, a, that you can distribute that in to the expression on the interior of the parentheses. And what you get, I usually go like this, whoopsie, what you get, a times x and a times y. And those are both represented in that expression there. A real number example would be like if you were like, you had two different, groupings, a 5 plus an 8, and you wanted to multiply that whole value by 2. First, you could add what's in the parentheses, but just for value's sake, for understanding this pattern, just know that you can also distribute that in, right? 2 times 5, 2 times 3, 10 and 6 respectively, which then add up to 16. So either way, this value would be 16, whether it's 8 times 2 or 2 times 5 and 2 times 6 added together. But this distributive property is what's being applied here. And so I can pretty much like factor this out as long as the value is the same. All right, pull that out. Then I have 5.001 plus 4.999, which is equal to 10. But this number is not in scientific notation. Remember, by definition, a number is only in scientific notation when it has one non-zero digit to the left of the decimal. And if we're going to be representing the number of significant figures in these particular numbers, remember you are limited by the one that has the least, but these are the same, and so we just have 4. What I can do here, there's a couple of ways I like to explain this, okay? This is a value. I cannot change. I have to be careful not to change this value. But I want to express this differently. I want to take this place value and put it into that exponent. Remember, this is a base 10 system, so if I'm just moving my decimal one place, I need to get a magnitude of 10 into that to multiply that. So that's kind of what we explain here. Okay, so if I'm going to have 1.0, I've moved that decimal one time. 1, 2, 3, 4, right? One of the other ways I like to write it is, let's say I pull that 10 there, and this is, whoops, get my multiplication in there, times 10 to the 4th. And I know that this is a commutative property. As long as this is all multiplication, it really doesn't matter what order I put it in. So then I can move this 10 into this, and thus I have the 5 here. Sometimes changing like this, sometimes when people do these quick exchanges in their head, they move the decimal in the wrong direction, like they go lower instead of higher. That would be incorrect. But that is a common mistake. And so I wanted to point out that common mistake and help you kind of work your way through that, how to conceptualize it while you're doing a little bit of mental math and just moving that 10, factoring out the 10, and then combining it with this base 10 here. And just remember that when you're multiplying magnitudes of 10 together, they have an exponent, that this is like, this means 1, even though there's nothing written there, and it would be 1 plus 4. So you can combine those, and then you have your answer here with 4 significant figures to match this. So mathematically, 1.0 is correct, but the significant figures are incorrect. And if that was you, that's why it was not marked as a correct answer. So just want to explain that. All right, I hope you're having an awesome weekend. See you soon.